This is Algebra Lesson 5-4, Point-Slope Form. In the last lesson, we took a look at slope-intercept form of an equation. There's another form of an equation that's very similar to slope-intercept form, but it's called point-slope form. Point-slope form is the equation y minus y1 equals m times x minus x1. This form of an equation is an equation of a non-vertical line that passes through the point x sub 1, y sub 1, and has a slope of m. This is the setup for getting an equation into slope-intercept form. So, when you use y minus y1 equals m times x minus x1, x1 comma y1 represents a specific point, and x comma y represents any point. You can use the definition of slope to find another form of a linear equation called point-slope form. So we are going to take a look at point-slope form today, and we're going to look and see how it relates to slope-intercept form and how the two can be interchanged a little bit. So first of all, we're going to look at writing an equation in point-slope form. If a line passes through the point 1, negative 4, and has a slope of 3, we can write the equation in point-slope form. The first thing you always want to do is you want to write the point-slope form of an equation so you can get in the habit of understanding how the equation works, and you can memorize the equation. So the equation is y minus y sub 1 equals m times x minus x sub 1. My point 1, negative 4 will become x sub 1, y sub 1. So I am going to plug in what I know into this equation, and then I'm going to solve for what I don't know, if I need to. Well, we're going to leave it in point-slope form, so actually we don't even have to solve it. So if x sub 1 is 1 and y sub 1 is negative 4, I'm going to do y minus a minus 4, and we'll clean that up in just a minute, equals my slope is 3, so m is 3, parentheses, x minus 1. So we're going to clean this up. Y minus a minus is a plus, so this becomes y plus 4 equals 3 parentheses x minus 1. This is point-slope form for an equation that goes through the point 1, negative 4 and has a slope of 3. As simple as that. Let's take a look at a second problem. If we have a line that passes through the point 8, negative 4 and has a slope of 2/3, we're again going to write the point-slope form of this line. So again, I'm going to write my equation, y minus y1 equals m times x minus x1. Remember the point 8, negative 4. This becomes x sub 1 comma y sub 1, and my slope is 2/3. So these are the points and the numbers that I'm going to substitute into my equation. So y minus a minus 4, we already talked about how while minus a minus is a plus, so y plus 4 is going to equal m, but m is 2/3 parentheses x minus 8. And that is the point-slope form for an equation. Point-slope form is very easy to write, not necessarily easy to work with once you have it in this form. However, if you understand the form, you can use it in many various ways. For example, we can graph using point-slope form if you understand how point-slope form works. So if I ask you to graph using point-slope form and I have the following two equations, y minus 5 is equal to negative 2/3 x minus 2. This is the first equation I have. The thing I need to do is I need to figure out what my point is. Hey, remember the point is x sub 1, y sub 1. And in the formula, y minus y1 equals m times x minus x1. X sub 1, y sub 1 are always subtracted. So as long as it's subtracted here and here, the points are actually going to be positive. So my x value is 2 and my y value is 5. So there's my point that I need. And my slope is always the value in front of x, so we know my slope is this value right here, so my slope is negative 2/3. So I have a point and I have a slope, and that's all I need to be able to graph an equation. Before we used the y-intercept and the slope, but the y-intercept was simply just a point, it just happened to cross the y-axis. Now we're just going to use a random point that we derived from our equation, and we're going to use our slope. So my point is 2, 5, so I'll go over 2, up 5. There's my point. My slope is negative 2/3, so I'm going to go down 2 and to the right 3. Down 2 and to the right 3. I have enough points. I can draw my lovely line, making sure you use your straight edges, please, because we need to be accurate. Draw your nice lines in. And once you have your line, make sure you label it. And in this case, we're going to label it with the point slope form. So y minus 5 is equal to negative 2/3 parentheses x minus 2. Notice how I labeled both my x and y axis. That's incredibly critical. Continue to do that, please. Problem number 2 here. I'm going to do it in purple so that we can set it apart from problem number 1. Okay, my point that I'm going to use should be the opposite of what is in front of it. So x minus 1, the opposite of negative 1 is positive 1. My y is y minus 2, the opposite of 2 is negative 2 is positive 2. So my point is 1, 2. And my slope is positive 1/3. So label my x and y axis here. I'm going to take the point 1, 2, and I'm going to graph that on my graph, and I'm going to use my slope. My slope is 1/3, so it's up 1, right 3. Up 1, right 3. And again, make sure you use your straight edge to draw your line, because we like to be accurate. And I missed, so I'm going to have to manipulate my line a little bit so it goes through my points. There we go. And of course, I'm going to label it. So y minus 2 is equal to 1/3 parentheses x minus 1. So simply, if you understand point slope form, you can graph it if you understand how to find the point and how to find the slope. You don't have to do anything with your formula. You can just leave it at that. Now, you can write the equation of a line given any 2 points. Okay? If I give you 2 points instead of giving you a point and a slope, you will have to determine the slope first. So you'll use the first 2 points to find your slope. Then you can use the slope and either one of the 2 points to write the equation. Okay? It doesn't matter which point you use. However, you will get different equations if you use different points. So what is the equation of the line in point slope form given the following? Points 5, 7, and 2, 6. So the first thing I'm going to do is, like I always do, I like to line up my points so that the y values line up and the x values line up, making it easier for me to make sure I'm taking the right numbers. So my slope is going to be y minus y, so 7 minus 6 over x minus x, 5 minus 2. I went top to bottom, so you have to go top to bottom on both numbers. So 7 minus 6 is 1, 5 minus 2 is 3, so my slope is 1/3. If I wanted to use the first point, okay, if I used the first point, okay, I would use 5, 7, because I'm going to get 2 different equations, so I'm going to write this twice. If I use the point 5, 7, my point slope form for the equation, okay, and I'm going to write the y minus y1 equals m times x minus x1 above here, so we have it handy. So I would do, if I'm going to use 5, 7, I'm going to use y minus 7 equals 1/3 parentheses x minus 5. So that would be a perfectly fine point slope form for the equation. If I chose to use the points 2, 6, maybe somebody else is like, oh, I like 2, 6 better. Well, the equation there is going to be slightly different. If we simplified it, it would be the exact same line. Okay, so here we're going to go y minus 6 is equal to 1/3 parentheses x minus 2. So depending upon which point you use, your equation will look slightly different, but they actually are the equation of the exact same line. Both of these equations are the exact same line. Let's look at problem number 2. If I was to do problem number 2 here, again, I'm going to line up my points, -7, -6. So I can find my slope. My slope is going to be -5 minus a -6, which means -5 plus 6, and -1 minus a -7. -5 plus 6 is 1. -1 plus 7 is 6. Excuse me. So if I choose the first point, if I choose the point -1, -5, I'm going to have y minus a minus 5 becomes plus 5 equals m, which is 1/6, parentheses, x minus a minus 1 becomes plus 1. So there's the equation if I use the point -1, -5. And if I use the point -7, -6, I will end up with y minus a minus 6 is a plus 6 equals 1/6, parentheses, x minus a minus 7 is x plus 7. So depending upon which point you use, I don't know why I circled the points with these this time, the equations would be y plus 5 equals 1/6, parentheses, x plus 1, or y plus 6 equals 1/6, parentheses, x plus 7. They are the exact same equation. Now, what is the equation of the line in point slope form for the above problems? So let's take a look at the two problems that we just did, and we're going to write the point slope form for the equation. So let's take a look at the purple problem. That was problem number 1. Let's take the form if it's y minus 7 equals 1/3, parentheses, x minus 5. Now, in order to get this into point slope form, I'm literally just going to simplify it and then write it in y equals form. So to simplify it, first I have to distribute the 1/3 through this. So I'm going to have y minus 7 equals 1/3 x minus 5/3. Okay. Now what I'm going to do is I'm going to add 7. Okay. Adding 7 over 1 is the same thing as adding 21 over 3. Because 1 times 3 is 3, 7 times 3 is 21. So now I can add my fractions together. So y will equal 1/3 x. 21 minus 5 is 16 plus 16/3. I have a tendency to leave my y-intercept in improper fraction form unless I need to graph it, and then I'll change it to a mixed number if I needed to graph it. Okay, now let's look at this for a second. You're like, well, what if I used the second equation? What if I didn't use the y minus 7 equation? I used the y minus 6 equation. Okay, so let's take a look at that one. We're going to do that same exact problem. So if I use the equation that was y minus 6 equals 1/3, parentheses, x minus 2, I'm going to do the same thing I did with the y minus 7. I'm going to solve for y, so I need to distribute this 1/3. So I'll get y minus 6 equals 1/3 x minus 2/3, because 1/3 times -2 is -2/3. Add 6. Adding 6 over 1 is the same thing as adding 18 over 3. So these cancel here, so you're going to get y equals 1/3 x. 18 minus 2 is 16, so plus 16/3. You'll notice that no matter which point you use, your slope-intercept form equations are exactly the same. Your slope-intercept form of the equation will be exactly the same, does not matter which point you use, which is why I prefer things to be written in slope-intercept form, because then we only get one answer. However, you do need to know how to write things in point-slope form, because point-slope form is the first step to getting slope-intercept form. So let's look at problem number 2. Since it does not matter which one we use, we should get the exact same equation either way. I'm only going to do the top equation. I'm going to manipulate the y plus 5 equals 1/6, parentheses, x plus 1. And I'm going to get this into slope-intercept form by distributing my 1/6. So y plus 5 equals 1/6 x plus 1/6. Subtract 5. Subtract 5 over 1, which is the same thing as saying 1 times 6 is 6, and 5 times 6 is 30, -30 over 6. So when we simplify this, the 5's cancel on the left-hand side, and I get y equals 1/6 x minus 29/6. And I don't need to do the second equation because I'll get the exact same answer as long as I do all my math correctly. So you can see how point-slope form leads to slope-intercept form. right? Because once you've written something in point slope form, if you simplify it and solve for y, you have it in slope intercept form. All right, the last concept we're going to look at in this lesson is using a table to write an equation. Okay, here we have a table that shows the amount of time Julio worked and his total wages. What equation in slope-intercept form gives Julio's wages at any time? And what do the slope and y-intercept represent? Okay, so the first thing we need to do is we need to make sure we understand the slope. Okay, and remember, the slope is the change in y over the change in x. So there's many ways you can do this. You can take two different points and do the subtraction that way, or the way I like to do it is I like to say, okay, from 130 to 210, what happened there? Well, if you look at it, from 130 to 200 is 70, from 100 to 200 to 210 is 10, so 70 plus 10 is 80. So there's an $80 change here. There's an $80 change here. There's an $80 change here. Hours worked, there's a 5-hour change here, 5-hour change here, 5-hour change here. So the change in y is 80 over the change in x, which is 5. 80 divided by 5 is 16. So the slope then is equal to 16. Right? So now I can choose any point on my table. I'm just going to highlight one. I'm going to highlight the very first point because they're smaller numbers. So my x value is going to be 5 and my y value is going to be 130. So my x sub 1 is 5 and my y sub 1 is 130. So I'm going to use the point 5, 130 to write my equation. So y minus y1 equals m times x minus x1. Excuse me. So y minus 130 is equal to 16 parentheses x minus 5. It asked for it in slope-intercept form, so I have to solve this for y. So y minus 130 is equal to 16 times x is 16x. 16 times negative 5 is negative 80. So now to solve this for y, I'm going to add 130 to both sides. And you will get y equals 16x plus 50. So there's my equation in slope-intercept form. And now I need to explain what my slope and my y-intercept represent. Right? In this particular case, if my slope is multiplied by x and my x is my hours worked, that means my slope is the amount of money that his hourly pay. Okay, so my slope here represents his hourly pay rate. He's obviously making $16 an hour. So slope is equal to his hourly pay rate. And the y-intercept is a fixed amount of income per pay period. So in other words, Julio will make $50 per pay period and then $16 an hour on top of that. What does he do that allows him to do that? It depends. Okay? Maybe you're a person who works on commission. You earn $50 a pay period whether you sell any items or not. But if you sell more items, you're going to earn $16 an hour on top of that, or $16 times every item you sell, whatever. So the slope is equal to the hourly pay rate here, and the y-intercept is a fixed amount. That he earns each pay period. So as you can clearly see, slope-intercept method comes directly from point-slope form. So point-slope form is really quite kind of important to be able to understand slope-intercept form. All right, today's closure question. Given the equation of a line in point-slope form, how can you determine the slope, the y-intercept, and another point that lies on the line? I want all three, please. All right, so how can you determine the slope, the y-intercept, and another point that lies on the line if you're given something in point-slope form? Think about that, and please write a complete answer.